Hello girls, today we are going to learn about RIP routing protocol, routing information protocol. Here you can see the classification. In routing protocol, there are two routing protocols, intra-domain and inter-domain routing protocol. Intra-domain means within the autonomous system, if any routing protocol is working, that is called as a intra-domain within the autonomous system. What is autonomous system? Autonomous system is a collection of computers and routers. So here RIP and OSPF are working for intra-domain, and BGP border gateway protocol, that is working for inter-domain routing protocol. Inter-domain means between the autonomous system. If any protocol is working, then that is called as a inter-domain routing protocol. Today our lab is about RIP, routing information protocol. This is based on distant vector algorithm. Okay, so here this is just an introduction about this protocol. You can see here this is based on the hop count. This routing protocol is working based on the hop count. Hop count means how many routers in between. You can see this is one hop. Okay, from R3 to N4 there is one hop. R2 to N4 you can see there are two hops. Like this it is working. So today we will see the routing protocol working with the help of Cisco Packet Tracer. Let us open the Cisco Packet Tracer as well as your lab manual here. Okay, so here the routing information protocol version 2 is used. Okay, RIP v2 that represent version 2. Okay, let's make a topology like this. Okay, this is the topology. In this topology, this is a autonomous system here. What is autonomous system? Few routers and few computers together, that is making one big network. This network is called as a autonomous system. So here now we are going to use the RIP protocol for the communication between the PCs. So here in this topology, how many networks you can see? You can see every interface of this router is a network. So this is one interface. This is one interface. 2, then 3, then 4, 5. So totally here we have 5 networks. 3 routers, 5 networks, and 3 PCs and 2 switches we have. So now we are going to make a communication between this PC A to PC. Here you can see this PC A to PCB. We are going PCC. This is a PCC. So we are going to make a communication, as well as you can make the communication between A to B or B to C or A to C. We can make a communication with the help of the routing information protocol. Okay, so let us open the packet tracer. Okay, let us open the packet tracer and we have to make a similar topology. So for this one, what I need a router. I'm taking the 1941. This is the router number I'm using. And I need 3 PCs. Okay, I need 3 PCs and 2 switches I need. So switches, I'm using the 2960. This is the switch number I'm using. Okay, so I have taken all the devices. Now I have to connect all the devices. So for the connection, I'm using copper straight through cable for connecting the switch to computer. Okay, any interface number you can use. Just for the uniformity, I'm using 06. Okay, then for connecting the switch to router, switch to router, I'm using gigabit 00. Here 01, fast ethernet 01 I'm using. Okay, so similarly I have to connect all other devices also. So let us connect this one, fast ethernet 0. Here I'm using fast ethernet 06 just for uniformity. Okay, even you can use any number. Then from here fast ethernet 01 to here gigabit 00. So we have connected. Okay. Then after that, I have to connect this PC with this router. Here I'm using gigabit 00. But for this connection, router to router connection, I cannot use this normal copper straight through cable. Which cable I have to use? I have to use the serial cable. Okay, so for getting the serial cable port, I have to do some modification in the router. So what I have to do, if you see, okay, without this one, if you see here, you don't have any serial port. Okay, only gigabit 00 and 01 you have. You don't have a serial port here. So how do we add the serial port? For that, go to the router. Okay, go to the router, go to the physical. So here first, if you want to do any modification, first you need to switch off the router, turn off the router, and this is the serial port. Drag and drop the serial port and switch on the router. Okay, now if you see here, uh, if you see here, you can see all the port. Okay, serial port you can see here. Okay, so now same like this, you have to do it for other routers also. First turn off, then drag and drop the port and turn on. Then similarly, you have to do this for this router also. Okay, turn off, drag and drop, then turn on. Okay, so now you can see if you place the cursor, you can see serial port in all the routers. Okay, all the router is it is having the serial port. So now you can use the serial cable for the connection. Okay, I'm using 010. Here also I'm using 010. Then for here I'm using 011. Just for uniformity, I'm using the same cable number 011 I'm using. Okay. So we have connected all the router, but still you can see all the cables that is not activated, port are not activated, they are coming in red color. So I have to activate all the port. So for that, I have to assign the IP address and I have to make the port status on. So how do I assign the IP address? Here I have a addressing table. Based on the addressing table, I can assign the IP address. So first I need to assign the IP address for the PC. PC, the IP address is 10.3. So let me assign the IP address for the PC. Okay. The IP address for this PC is 10.3. Subnet mask is 255.0. Then the default gateway. Default gateway is 10.1. So what is default gateway? Default gateway is nothing but from this computer, if you want to send and receive any messages, first it will go to this interface, gigabit 00, this interface. This interface is called as a default gateway. Default gateway always we will give the first address in the network. So normally the default gateway address will end with 1. So whatever the address you are giving here, this is the address of this interface, gigabit 00. So let me go to this router. Okay, let me go to this router, the gigabit 00 interface. Whatever the address I gave here as a default gateway, same I am giving. The mask is 255.255.0 and make the port status on. Then only that this red color will turn into green color, that will be activated. So make the port status on. Now close it. Now you can see this is coming in green color. Same like this, you have to do it for other PCs also. But here for this PC, what is the address? Okay, IP address is 30.3. This network is 30.3. So let me go to this network, this PC. Okay, IP configuration. The address is 30.3 and the mask is 255.0 and the default gateway is 30.1. So whatever I'm giving here, same I have to give it here. Okay, gigabit 00. This is the default gateway. Let me open the router. Okay, let me open the router. So go to the gigabit 00. Give that same address. Okay, so here this is 255.0 and make the port status on, so it will be turn on. Okay, it will come in the green color. So same like this for this PC. What is the address? The address is 209. Okay, so let me go to this PC. Let me go to this PC. So here, just for uniformity, here also I'm giving 3. Okay, for all the PCs, it is coming in 3. And the default gateway address is 201.1. So whatever I'm giving here, the same address where I have to give in this interface. So this interface is gigabit 00 of this PC, this router. So let me go to this gigabit 00. Okay, give the same address and give the subnet mask and make the port status on. Okay, so as of now, all these ports are activated except the serial port. I have to activate and I have to give the IP address for this port. So what I have to do for this serial port, what is the IP address? Here you can see in the addressing table. For this port, the IP address is here you can see this is the IP address for serial 00. So they gave this one 10.1.1.1. See the mask address. This is 255, 255, 255, 252. So here what I have used is 010. Here they have used 000. This is not an issue, but the address I have to give the same address. So it will be easy for me. So let me open this port. Okay, let me open this port. The port number is serial 010 and the address is 10.1 and the mask value is 255.252 and make the port status on. This is 10.111. Both of them are in the same network. So similar address I have to give here. This is 1.11. Here I'm going to give 1.2. So let me open this router. Let me open this router. Go to the interface 010 interface. Okay, so the address is 10.1.2. Okay, then the mask value is 255.255.252 and make the port status on. Now you can see this port also activated. Okay, let me give the address for these two ports. Okay, for this one, what is this network? This network is 10.2.2. Okay, so let me give the similar address. Okay, so let us start from here because I have copied that 10.2.2. So what is the port number? This is 0111. So let me go to this port. Okay, what is this address? This one. And the port number is 255.255.252 and make the port status on. Similarly, here 011. See the port number. This is 011. Let me give the IP address 10.1. Okay, then make the port status on. So now all the ports are activated. All the addresses are given. Okay, now, but I did not install any routing protocol. Just I made a topology and I have assigned the IP addresses. Let me try to ping between these PCs, this PC to this PC. Okay, before giving any routing protocol, if I try to ping, here you can see it is failed. Okay, so what I have to do is I have to use any routing protocol to tell the router to take the route. Okay, routing protocols are used to give the routes for the packets. So I have to use any of the routing protocol, RIP or OSPF, any of the routing protocol. So let me use the RIP protocol for giving the path for these packets. So how I have to use the routing protocol? So the easy method is just to go to the router. I have to add the network addresses in the router. Okay, so first of all, I have to select the routing protocol. I'm using RIP protocol, routing information protocol, and I have to assign the network addresses here. Okay, what are all the networks we have? I have to add all the network addresses here. So just for our understanding, let me add all the network addresses before going here. So what is this network address? This network is 172.30.10.0. This is the network address of this side. Okay, then what is this network address? This one is 30.0. This is the network address of this one. Okay. So for this network, this is the address. For this network, this is the address. For this network, what is the address? Let me add the address here. Okay, this network is 10.1.1.0. This is the address of this network. Okay, for this network, the address is 10.2.0. This is the address of this network. And for this network, this is a difficult number. Let me copy the address of this network. This network address is 10 point, sorry, 209.165. This is the network address of this network. Okay, so totally how many networks you have here? This is 30.10, this is 30.30, this is 1.0, this is 2.2.0, this is 1.1.0 and 209. So 1, 2, 3, 4, 5 networks you have here. Okay, so let me add the addresses in the router. Okay, addresses in the router for getting the routes for the packets. Okay, so how I am adding the network addresses? First, I have to choose which routing protocol I am using, RIP protocol I am using, and here I am adding the address commonly. Which address I am adding? Here the network is 30.10. Then I have here 30.30. For both of them, the common address is 172.30. So here I am adding the address, okay, adding the address 172.30.000. So um, this will represent both the network. That is, for this router, for it will represent this network 30.30. Then I have to add this network also. Here, what is the difference? 1.1.0, 2.2.0. See, so here the common number is 10. So if I add the address like this, it will represent both the network 1.1.0 network as well as 2.2.0 network. So I'm adding the network address like this. Okay, this represent both 1.1.0, 2.2.0. Both the network addresses are represented commonly. So I'm adding network address here. So this router, it know the route for both the networks. Which network? It knows the route for this network, this network, this network. I'm introducing all the network address for this router. Okay, so let me add this address also. This address also, this is 0. Okay, add this network address also. So now this router knows the route for all the other networks. So let me do the same process for all other routers. Okay, let us go to this router. Let us go to this router, choose the RIP protocol. Okay, add all the network addresses. Add all the network addresses. Similarly, you have to do it for this router also. Choose the RIP protocol. Okay, so now we have added all network addresses for all the routers. Okay, then one more process we have to do it for getting the updates in the routing protocols. Okay, so what I have to do in the middle router, actually it is connecting the router 0 and the router 1. So in the middle router, what I have to do is I have to add one more command that you can see in your okay. This command you can see in your lab manual. Let me open the lab manual. So here, okay, so you have to add one more command. So this command is important, then only the routing informations will be updated. So what is that command? Actually, we have used all the shortcuts. These are all the um, commands for adding the networks. Let me show you the important command, then only the routing updates will be done. Okay. So this is the important command that you have to write it in the middle router. What is that command? Default information originate. This command you have to use it in the middle router. Then only this command is added to its RIP configuration. Okay, see here. R2 will advertise a route to the other routers only if you add this command. So you have to add this command in your middle router. So how do you add? Go to the router. Okay. Go to the router. Go to the command line interface CLI. Okay. So we are in the router. Already we are in the router rig. Otherwise, just I will show you from the beginning how you have to add this command. So now we are in the user execution mode. How will you get inside the privilege mode? Enable. Then after that, if you want to go to the config mode, config T, then after that you have to go to the router RIP. Okay, router RIP. Now you are in the router RIP mode. Here you have to add this default information originate. This command you have to add. Okay, so let me copy paste the command. Okay, now we have added the command. Okay, so let me try. Let me try whether now we are able to ping or not. Okay, let me try. We have added all the necessary commands. Okay, let me try from this PC to this router. Is it successful? Yes, it is successful because this is a default gateway. So this is easy. So it will be successful. Then this PC to this router. Let me see. This is also successful. Then this PC to this PC. This is also successful. Then this PC to this router. This is also successful. Let me check this PC to this PC. Yes, this is also PC0 to PC1 also successful. So all the communications are successful now. You can see some other commands also in your lab manual. You can see. We can see this is the command that is used to add the static route. So what is this command? IP route 00000209. What is this command? Here you can see if you want to add any default route. That means if you are getting any packet, you don't have any destination address, then where the packet will go, that will be sent to the default route. So that route is called as a static route. So how can you add the route? So IP route 00, okay, 00 is the mm, network mask value, IP address, okay, IP address and the mask value. Then this is the default route. Okay, so in this way you can add a default route. This is optional command, so you can try this also. This is the command that is used to add a static root or default root. Then you have one more command here. You can see. If you want to see the routing table, if you want to see the routing table, how can you see? By using this show IP root command. Let's see this command. Okay, you know one thing, all the show command will work only in the privilege mode. So first exit to privilege mode, then use the show commands. So here only you can use the show commands, show IP root. Okay, now you can see show IP root, it is showing you all the roots. Here you can see this is connected 10.1.0. This is directly connected. I have used the command in router 2. This is directly connected. Then this is a local connection. 1.1.2 is the local connection. And this is also 10.2.2 also directly connected with this router. And 172.30.00 it is connected by using the routing protocol RIP or that represent routing protocol RIP. You can see this is connected via 10.1.1. This is connected via 10.2.2. Okay, this is variably subnetted. That means this is also connected. Okay, so here you can see the routing table. Okay, routing table with the help of show IP root command. Other than this, we have many commands. Okay, if you want to see the interface, you can see show IP interface brief. Okay, this is also the command. I will show you the another important command. This is a command that is used for making the interface as passive. Passive means we are making the interface inactive. Why we are making the interface inactive? We don't want to do any updates in the interface. Command stops routing updates of the specified interface. This process prevents unnecessary routing traffic. So this command also a optional command. What is the purpose of this command is, for example, if you take this if you take this topology, so here this interface is a default gateway for this PC. So here there is no need of doing any routing updates. Where you need routing updates, you need routing updates in this interface. Okay, anyway, this interface is a default gateway. So no need of adding any updates in this interface. So we can make this interface as a passive interface. Similarly, this interface, gigabit 00 interface. Similarly, here gigabit 00 because they are directly connected. No need of doing any updates in this routes. So here we can make this interface as a passive interface. So this will avoid any unnecessary traffics. So what is the command for doing the passive interface? Just you have to go to this router. Okay, go to this router. Let me show you. Okay, let me exit from all these things. Let me show it from the beginning. Okay. Okay, now you are in the user execution mode. So what you will give, enable. Okay, let me start from the beginning. Let me start from the beginning. Type the command enable. I want to make the interface as passive interface. Enable. Then you have to go to the config mode. Now we are in the privilege mode. If you want to go to the config mode, config T. Then after that, you have to go to the router mode, router RIP. And this is version 2. You can write version 2. Okay, just we are using the router. RIP protocol with version 2. Then after that, you have to write the passive interface. Let me see the command. You can see the passive hyphen interface and you have to write the interface number. Okay. So here passive hyphen interface, then the interface number is gigabit 0/0. Even you can use the shortcut int. Okay, so now this interface is made it as passive interface. Okay, so this is the way of making the interface as passive. This will avoid any unnecessary traffic in the network. This is just an optional command. So that's all about this routing information protocol. So this is a easy method. If you want to add the network in command line interface, that is also you can make. Just exit. Just exit. I already show you the command. Here you can see in the command line interface command. See here network, this is for the command for adding network. But simply in the shortcut, we have added all the network addresses. So similarly, we can use the OSPF for intra-domain routing protocol. So far we have discussed RIP protocol. Okay, that's all. Thank you.